Gravity wheel. This is an attempt at a gravity wheel. Not a successful one. The whole idea of this wheel, it's very low friction on the bearing. It turns very easily. So all we want to get is some imbalance on each of the spokes where one weight is displaced to the side and causes it to turn. These weights are magnetic, they're ring magnets. This is also a magnetic deflector which can push one magnet to the side, causing it to turn. And you might get the impression that as long as we could put magnets on each of the spokes and get the same mechanism happening as it turns around, as this one comes around, it will also deflect and the thing will keep turning. But that's not what happens. These are, the weights are pivots. They're basically pivoting weights on a nylon backing, an aluminum tube which slides over the carbon fiber peg, which is basically a section of these carbon fiber poles which you buy for dome tint replacements. We have very little friction, again, so the pivot can turn very easily. These things can turn on their pivot very easily. Alright, so what happens when we add more weights? First of all, if you add the exact counterbalance so that you've got 4, that we've still got balance, right? We've still got balance on the wheel. Now then, if you deflect one of them, you're still getting some turning. At this point, you might think that the wheel could work. Let's see what happens when you add the rest of the complement. First of all, you can't really test it if you've just got 6 because there's no balance. 6 doesn't work because there's no balance. What happens is you've got this space here, and it always wants to stop at the gap. So let's put the full complement of 8 on there, and you'll see what's happening. Now it's balanced, you can turn it. Now what happens with the deflection? Let's deflect one of them. You see, we no longer get, you can get some turning, but remember, this deflector has to stay stationary. We want the deflector to be in one position. As the magnets come around, they come into the deflection magnetic field, they move out, and you want the wheel to be constantly imbalanced with the one deflected weight turning the wheel. But in fact, it does not. Why isn't it? For one thing, the geometry of the thing, now here we go, but again, the geometry of the thing prevents any more than one of them from deflecting at a time. Now when there's just one bar and no other weights on the wheel, that works. But when you have the full complement of 8 weights, the one deflected weight can't raise both its opposite and these other 2. It's basically you have got one trying to raise 3 on the other side at any one time. And you might think, well, if I can deflect 2 on this side, or 1 or partially 2, then that might do it as well. But you've got another factor involved here. With this system, you're using a magnet to deflect the weight. It has to be fairly far over in order to do the deflection. And you've got some movement. But it doesn't bring the second one into position. The second weight has to be brought into position. But what happens is that the same magnetic force which is deflecting this one sideways is interfering from this one dropping. It's actually pushing this one upwards. Okay? You run into problems. Now this one will begin to come around. If I bring it up, it's also pushing downwards, but it's also pushing upwards on the one above. So you've got two things working against you. One is that you don't have enough deflection on the right hand side to balance the number of weights that need to be lifted on the left hand side. Secondly, your deflection isn't only causing a gravity imbalance, it's also causing an upward deflection on the one which is coming down into position. So it's countering your gravity. So for those of you who want to make a gravity wheel, I'd be very happy to hear if anyone gets one working with a different system. But this strict magnetic deflection won't work. There's another type of wheel called the Andes motor, which some of you might be familiar with. It has an offset wheel, an offset axis, and some of these materials are from that project. It also has an outer ring where the magnets are on bearings and they're sticking to the outer metal ring as it goes around. That one failed for similar reasons. One of which there was too much friction in the system, but this one you can't blame friction because the bearing has virtually none. It turns freely. The problem is in the physics of the deflection and the imbalance.